An arithmetic progression AP is given as 600 plus 650 plus 700 plus 750 plus the progression continues. Determine part A, the 30th term of the AP. Part B, the sum of the first 30 terms of the AP. Let's go to part A, the 30th term of the AP. Now, one thing that you need to understand when you're solving this question is how to get the nth term of any arithmetic progression. So how do you get the nth term of any arithmetic progression? You get it like this: a plus n subtract 1 d, whereby a is the first term of the progression, then n is the position of the term. Let's say the first term. If n is the first term, we're talking of the first term, n is equals to 1. If we're talking of the second term, n is equals to 2. Like in this case, we want the 30th term. So therefore, n will be 30, the position of the term. So this is how we actually get the nth term of an arithmetic progression. And this is what you're going to use in this part. So what we need to identify is A. What is the first term? The first term is 600. So first term is 600. Then D is the common difference of the progression. D is the common difference. D is equals to the common difference. Now when you look at this progression, 600 to 650 to 700 to 750, you can see there's a common difference. If you take you want to get the common difference, you simply do it like this. You take like a 650, subtract 600, that one you get 50. Or you can get 700, subtract 650, you get 50. So you can see the common difference from one term to the next. You're actually having the common difference as 50. So that is the common difference. Now having these, and now using this formula here, how to get the nth term, you'll be able to get the 30th term. So the 30th term is equals to, so 30th term is equals to A, which is the first term, that is 600, plus n, that is a position of the term. You're required to get the 30th term, so n will be 30. Then subtract 1, multiply by the common difference, which is 50. So make sure you have done the correct substitution. And I'll use a calculator for these. So this will be 600 plus, this will be 29 times 50. When you use the calculator, this will give 2050. 2050. That is the 30th term. Part B, the sum of the first 30 terms of the AP. Once again, for you to work out these, you need to know how do you get the sum of a given number of terms of any arithmetic progression. So the nth term, not the nth term, but the sum of the n terms. Like in this case, we want to get the sum of the first 30 terms. So this will be given by this formula, n divided by 2 into brackets 2a plus n minus 1 d. So this is the formula of getting the sum of a given number of terms of an AP. So what you need to do is just substitute. We want to get the sum of 30 terms, so n will be 30. So sum of the first 30 terms will be S30 is equals to n, the position of the term, the 30 terms. So n will be 30 divided by 2, and then 2 multiplied by a. Remember that a is the first term, which is 600, then plus n is 30, subtract 1, then multiply by the common difference we got in the first part, that is 50, like that. So we just need to substitute. So S30 will be given by, this will be 15, 30 divided by 2, then multiply by 2 times 600, that will be 1200, plus 29 times 50. So just use a calculator to work out this. Make sure you've done the correct substitution, and this will simply give, when you work out this using a calculator, you get 39,000 39,750. That is the sum of the first 30 terms of the AP. Question 2. The quadratic equation 5x squared plus kx plus 20 is equals to 0 has only one root. Determine the possible values of k. Now, the first thing that you're supposed to understand before solving this question is the standard quadratic equation. You're going to take the standard quadratic equation and then we compare it with whatever we have here. So let me write this equation alongside the standard quadratic equation. So we have 5x squared plus kx plus 20 is equals to 0. The standard quadratic equation is ax squared plus bx plus c is equals to 0. So compare the terms and establish the values of a, b and c. So from these, a correspond with that, so a is equals to 5. Then b corresponds with k, that is the coefficient of this b, so b therefore is equals to k. And then c, that is a constant, c is equals to 20. Once we've done that, there's something that we need to understand that will help us to get the value of k. If this quadratic equation has only one root, then it means in a standard quadratic equation, if it has one root, then it means that when you take b squared minus 4ac is equals to 0. That is the one that is going to help us to get the value of k. Now that we know the values of b, a and c, we just need to substitute it there. This is one way that we can get that. The second way, if this is a standard quadratic equation and it has one root, then if I take b divided by 2, square that is equivalent to a multiplied by c. So these two will help us get the values of k. So let's start with method 1. And method 1, for method 1, I will use this one. B squared minus 4ac is equals to 0. And now you substitute the values of a, b and c. So the values of a, that is a b squared, so b is k, so that will be b squared will be k squared minus 4ac, that is 4 multiplied by a is 5 and c is 20. This one is equals to 0. So you can see that it is possible to get the value of k. So k squared, therefore this will be given by, so if you multiply these 4 times 5, that is 20 times 20, that will give 400 is equals to 0. Make k squared the subject of the formula. K squared is equals to 400. And now to get k, you simply get the square root of both sides, and this will give k as the square root of 400 will be positive or negative 20. That is method 1. That is method 1. So method 2 is where you're going to use the second one here. B divided by 2 squared is equals to a multiplied by c. Remember these values. B is k, so this will be k divided by 2, you square that, is equals to a is 5 and c is 20. So k divided by 2 squared will give k squared divided by 4 is equals to 5 multiplied by 20, that will give 100. So multiply both sides by 4 to make k squared the subject of the formula. So k squared is equals to 100 times 4 will give 400. And from here, getting the value of k, so k, get the square root of both sides, k is equals to the square root of 400 will be positive or negative 20. So that is how you solve for the value of k using the two methods. without using mathematical tables or a calculator, evaluate. That is a question on logarithms. Now let's look at the numerator and then look at the denominator. So when I look at the numerator, I can see logarithm of 125 plus logarithm of 64. So looking at logarithm of 125, it is possible to express 125 in index form using the base of 5 like this. So 125 is the same as 5 cubed. And then 64, I can write that on in index form at the base of 2, and this will be 2 raised power 6. Now having these, then looking at the denominator, let me look at the denominator. Denominator, we have logarithm of, that is the 6th root of 5. The 6th root of 5. So the 6th root of 5, you can also write it like this. So the 6th root of 5, can simply write it like 5 raised power 1 over 6, and then plus logarithm of the cube root of 2. Cube root of 2. So cube root of 2, you can write it like this, removing that square root sign or the cube root sign, can write it as a 2 raised power of that. Now having these two for the numerator and the denominator, now we can simply substitute and see what we can be able to simplify. So let me proceed with the numerator. So logarithm of 125, I shall have logarithm of 5 cubed, then plus logarithm of 64, you get logarithm of 2 raised power 6, then divided by logarithm of the 6th root of 5, be logarithm of 5 raised power 1 over 6, plus logarithm of the cube root of 2. This will be logarithm of 2 raised power that. Once you've done that, remember these are basic law of logarithm. Given, so note this, given logarithm of a raised power n, this one can be simplified as n logarithm of a. This is very important, and that is what you're going to, this is what you're going to use here in this particular question. So logarithm of a raised power n is the same as logarithm n logarithm of a. Now applying that in the numerator, we shall have logarithm of 5 cubed will simplify to logarithm of 3 logarithm of 5. Then logarithm of 2 raised power 6 will be 6 logarithm of 2. That is for the numerator. For the denominator, logarithm of 5 raised power 1 over 6 will be 1 over 6 logarithm of 5. Then plus logarithm of 2 raised power third will be a third logarithm of 2. So what we've done is simply application of this law here. Logarithm of a raised power n is equals to n logarithm of a. Now once you've done that, just look at the numerator and the denominator and see what you can factor out. So when I look at the numerator, I can factor out 3. So 3, factor out 3, and you remain with logarithm of 5. 3 is common in both of those terms. Then plus this will be 2 logarithm of 2. You factorize that and then go to the denominator and see what you can factor out. 1 over 6 and a third. You can factor out 1 over 6. 1 over 6 is common. So when you factor out 1 over 6, you remain with logarithm of 5 plus when you factor 1 over 6 in a third logarithm of 2, you remain with 2 logarithm of 2. Now looking at the numerator and the denominator, you will notice that whatever is in the brackets in both the numerator and the denominator can divide out. So this one, you can divide this one, and when you divide that, you will remain with 3 divided by 1/6, and this one is the same as 3 divided by 1/6, and it will simplify to 3 times 6, and that will be 18 as the solution. Make x the subject of the formula in y is equals to a divided by b power x. When you look at this question and look at this equation, you'll notice that getting or making x the subject of the formula would be quite challenging. Therefore, the best way is to first introduce logarithms on both sides of the equation. So let me do that. So introduce logarithm on both sides of the equation, so that you have on the left hand side you have logarithm of y is equals to logarithm of a divided by b raised to power x. After doing that, you need to recall some basic laws of logarithms that are going to help you to finish up with this question. And the first one, recall this. First one, if you're given logarithm of a divided by b, this one is the same as logarithm of a minus logarithm of b. That is the first one you're going to use. And then the second one, given logarithm of a raised to power n is the same as n logarithm of a. So these two will help us to make x the subject of the formula. Now let's go back to our question. So from this step here, we shall have logarithm of y is equals to, now look at logarithm of a divided by b raised to power x. We're going to use this law I've written here. Law number 1 is what you're going to use. Logarithm of a divided by b is the same as logarithm of a subtract logarithm of b. And therefore this one will simplify to logarithm of a subtract logarithm of b raised to power x. Then from there, I'd like you to look at logarithm of b raised to power x, and then look at this law written here, number 2, logarithm of a raised to power n. So this one will simplify to logarithm of y is equals to logarithm of a, and then logarithm of b raised to power x, according to this law number 2 I've written here, will be x logarithm of b. Now, since you're making x the subject of the formula, I will look at this x logarithm of b, and I'll try to bring it to the left hand side. So when I bring this on to the left hand side of the equation, I will have x logarithm of b, and then for logarithm of y, this one I'll take it to the right hand side. And you know, when you're taking a value to the left hand side or the right hand side, the sign changes. So if you're actually having it as negative, when you transfer it to the other side, to be positive. That is very important. Or simply, I can say this, that to get x logarithm of b to the left hand side, you simply add it to both sides, because what you're doing is eliminating it on the right hand side. So this is what you're going to have. X logarithm of b is equals to logarithm of a, then subtract. So what you've done is subtracting logarithm y on both sides, or simply taking logarithm of y to the right hand side of the equation. So logarithm of a subtract logarithm of y. Now from this point, remember we are making x the subject, so to remain with the x on the left hand side, you simply divide both sides by logarithm of b. like that. And this one will give x as logarithm of a minus logarithm of y divided by logarithm of b. And we've made x the subject of the formula. So that is how you're supposed to work it out. The unshaded region on the Cartesian plane satisfies the inequalities x plus 3y less than or equal to 21, negative 3x plus y less than negative 3, negative 3x plus y greater than or equal to negative 13, and x plus y, 3y, is greater than or equal to 11. So the figure is there, and you can see the shaded region. This is called the required region or the feasible region. It is bounded by all those lines, the inequalities given there. Now the question is, find the maximum value of x plus 4y for the integral coordinates p, x, y lying in the unshaded region. So the keywords here to note is the maximum value of x plus 4y for the integral coordinates, meaning that the coordinates that you're going to get for x and y must be whole numbers only. Whole numbers, no decimals, no fractions for x and y. Now what are we going to do? What is going to guide us is the previous knowledge that we have in linear programming, because this is optimization. And what we are given here, x plus 4y, is the objective function. So this is the objective function, and this is what we use to optimize. This is what we use to optimize, either to get the maximum value or the minimum value. And to do that, there are two ways of optimizing, finding the maximum or the minimum value. One, you can draw a search line. You can decide to draw a search line, or you can use the corner point. You can use the corner points of the feasible region or the required region. So those are the two ways: use of a search line and use of the corner point of the feasible region. Now in this particular question, I will simply use the corner points of the feasible region. Look at the corner points. So we have this point which is, let me check, this is 3. I can try to minimize this one a little bit so that I can see. Look at this point that is here. So this is 3, 6. So we have a point here. This is 3, 6, and then we have this point here. The corner point of that point is this is 6, 5. So this is 6, 5. And then we have this one down here. This is 5, 2. And then we have this one. This one is 2, 3. So those are the corner points. And it's also very important to note that the maximum or the minimum point doesn't have to lie exactly at the corner. It can even lie somewhere inside here in the feasible region. So I will have to test the corner points, and then I will pick several here. Like for example, I can say to pick points like I can pick 5, 2. Let me see. Can pick 5, 2. Can pick this one. 5. Let me see. Not 5, 2. 5, 2 is there. Is already there inside. So inside that place, I can pick. Let's say a point like 5, 5. I can pick 5, 5. This one. This one is 5, 5. And also I can pick this one like. This one is 4, 4, 5. So I can test any of these points. The one that will give me the maximum value, then that will be the solution in this case. So let me prepare a table here that I'm going to use for x and y, and for the coordinates that I'm going to use. So x, so you have x, y, and then the function x plus 4y. X plus 4y. So let me have the points. Yeah, so I'm testing. The first one will be, so the first one that I want, let me start with the corner points. And it is also very important to understand that there are some points here that will not be included. Look at these 2 points, 2, 3. 2, 3 will not give us the solution. Why? Because 2, 3 lies on the broken line, and all the points that lie on the broken line will not satisfy the inequalities. The points will not be included because they simply lie on the broken line. So 2, 3 and 3, 6 will not form part of our solution. So we're left with the corner point 6, 5, 6, 5 and 5, 2. So 6, 5 and 5, 2. So those are the two that we have, the corner points. So simply substitute x and y so that you can get x plus 4y, x plus 4y. So for 6, 5, you get, this will give 26 when you simply substitute. When x is 6, y is 5, substitute in these x plus 4y, you get 26. Then for 5, 2, you get these will be 5 plus 8, that will be 13. All right, then those are the corner points. Then I can pick these two, 4, 5 and 5, 5, 4, 5, and then lastly 5, 5, so that I can test these as well. So for 4, 5, these will be 4 plus 20, that will be 24. And then 5, 5, these will be 5 plus 20, that will be 25. So now, having tested those 4 points, the one that gives the maximum value will be the solution. So I've tested the corner point, 2 corner points, and then 2 other points inside there. Then I've picked 4, 5 and 5, 5. So now check which one gives us the maximum value. It is the first one here, 6, 5. So this is the one that gives us the maximum value, and therefore the maximum value of x plus 4y for the integral coordinates p x y lying in the shaded region will be 26. It will be 26, and we got that by simply testing the corner points. I said you can also draw the search line and slide using a set square and a ruler, and you still get the same thing. So 6, 5 as the value of x and y, and that gives the solution the maximum value as 26. An aircraft flew due west from point A, 39.64 degrees north, 50 degrees east, to B, 39.64 degrees north, 20 degrees west. Calculate the distance covered by the aircraft correct to the nearest kilometers. Take pi to be 22/7 and radius of the earth 6370 kilometers. Now when you look at these 2 points, A and B, you notice that these points lie on the same latitude but different longitudes. And then you need to identify, do these points lie along the circle of latitude or the great circle? These points lie on the circle or the parallel of latitudes. Circle of latitudes or parallel of latitudes, or the small circle. Now after identifying that, how do you get distance in kilometers between 2 points that lie along the circle of latitude? Now this is how you get the distance in kilometer. So distance is given by theta over 360 multiplied by 2 pi r cosine of alpha, where theta is the longitude difference between the 2 places, then alpha is the latitude angle. So once we know that, now we need to identify the longitude difference. So longitude difference in this case will be given by, look at point A lies on longitude 50 degrees east, and then B 20 degrees west. So to get the longitude difference, you simply add. You get this is a 50 plus 20, and these will give 70 degrees. Then the latitude angle. These places lie on the latitude 39.64 degrees north. So the latitude angle is 39.64 degrees. Now once we do that, now we can get the distance AB. Distance AB therefore is equals to theta, which is 70 degrees, divided by 360 multiplied by 2 times pi, 22/7, times the radius of the earth, which is 6370, then multiply by the cosine of the latitude angle, which is 39.64 degrees. So what you need to do here is simply use your calculator carefully, and when you do that, this is what you're going to get. And remember, it is to the nearest kilometer, so you'll get 5,995.4075. We leave it at that point. So when you round off this one to the nearest kilometer, you get 5,995 kilometers. In the following figure, A, B, C, D, and E are points on the circumference of the circle. Line AB is parallel to line DC, and line FAG is tangent to the circle at A. Angle GAB is equals to 25 degrees, and angle ABC is equals to 100 degrees. So you can see the figure there. All the angles are indicated. Study that figure carefully so you can see all the angles. And then we go to the question: determine the size of angle, that is A, angle BAC, and then angle AED. So let's come to the figure and try to fill all the possible angles that we might be able to do using all the angle properties that will be applicable in this particular question. Now, let me look at parallel lines. So I can see the parallel line, then I can see the tangent. This one angle I can get here. So look at angle BAC. Angle BAC is equivalent to angle ACB, and the reason is these are angles in the alternate segment. The angles in the alternate segment. So therefore this angle is 25, and therefore this angle is 25. Angles in the alternate segment are equal. Then look at triangle ACB. So you have 25 degrees plus 100, that is 125. So the sum of angles in a triangle should be 180, and therefore this angle here, this will be 180 subtract 125, this will be 55 degrees. Again, look at this angle here. There's an angle here, this angle here, that is angle DAC, DCA. So angle DCA is equals to angle CAB. Angle CAB. These are vertically opposite, not vertically opposite, but alternate angles, not transversal. Angles on a transversal. CA is a transversal, DC is parallel to AB, and therefore CA is a transversal, and then these angles are alternate. They are alternate angles in a transversal. So therefore this is 55, and therefore this one should be 55. Now after getting that, there is another one that you can still get. Look at angle DCA. Angle DCA is equivalent to angle, not equivalent, but we can use another property here. So if I take that angle plus angle DEA, that should give a sum of 180. Reason: opposite angles in a cyclic quadrilateral should add up add up to 180 degrees. Opposite angles in a cyclic quadrilateral add up to 180 degrees. CDEA is a cyclic quadrilateral. CDEA, and therefore this particular angle here plus 155, that should give 180, and therefore this one should be 125 degrees. Let me see whether we can still get another angle, or we have already obtained the required angle. Let me go to the question and see. Angle BAC, we got that. BAC is equals to 55 degrees. So we got that one as 55 degrees. Then the other one is angle AED. That one we worked it out here. We got it by taking 180 subtract 55 degrees, and that was 125 degrees. Then for BAC we used the reason. Let me see. BAC we actually got that one by the sum of angles in a triangle. So we got 180 subtract 125. It's always good to show all the workings that you have used. So that is how you're supposed to get the two angles. The triangle ABC with vertices A10, B30 and C12 is transformed by the matrix T is given there, 3k, 1.6, 3k, negative 0.9 onto triangle A prime, B prime, C prime. Given that the area of the triangle A prime, B prime, C prime is 6 square units, determine the value of k. Now when you look at this particular question, first of all you need to be very careful to know exactly what it is testing. Now when you look at you're given the matrix, and then you're given the object, which is ABC, and then you have the image. The image of ABC is given, A prime, B prime, C prime. Then you're given the area of the image and the matrix. So one particular concept that you're being tested here is whether you understand that the area scale factor is equivalent to the determinant of the matrix of transformation. In this case, the matrix of transformation is given here, that is T. So the area scale factor is equivalent to the determinant of the matrix of transformation. How do you get the area scale factor? Area scale factor in this particular question will be the area of area of the image divided by the area of the object. The object that should give us the determinant of this matrix of transformation. So the first thing that you need to get is the determinant. So let us get the determinant. You know how to get the determinant of the matrix of this 2 by 2 matrix. So you get the product of this diagonal, 3k multiplied by negative 0.9, then subtract the product of the other diagonal here, and that is 1.6 times 3k. So this one should give negative 2.7k subtract 4.8k. So that is the determinant. Now once you get the determinant, now let's check, do we have the area of the image? It is given as 6 square units, but we don't have the area of the object, but we do have the coordinates of the object. So carefully look at those coordinates, 10, 30 and C12. There's something that you notice when you look at these coordinates carefully. Notice that this one, we form a triangle that is easier to get the base and the height. Let me sketch it so that you can see. If I sketch it like this, this is where we have A10, can see this one lies along a straight line. Then B, B 3 0, then C will be 1 2. This one is actually forming a right angle triangle. Look at those coordinates carefully, so that you get the displacement, the height. The height will be given by the y displacement. So from 0 to 2, those are 2 units up. Then the base will be given by the horizontal displacement, that is the x, or you check the x coordinate. So from 1 to 3, from 1 to 3, that is 3 minus the displacement will be 3 minus 1, which will be 2. So the base will be 2. Then the height we are looking at the y displacement from 0 to 2. So you can see we have a triangle. We are forming a triangle that is having the base as 2 and the height as 2. So it is possible to get the area of that triangle as a half using half base times height. Base is 2, height is 2, and this will give 2 square units. So now we have the area of the object and the area of the image. So determinant, so therefore the determinant which is given by negative 2.7k subtract 4.8k is given by the area of the image. The area of the image, which is 6, divided by the area of the object which we just obtained, which is 2. And so this will give a negative 2.7k minus 4.8k is equals to 3. And this one simplifies to, let me just simplify this one, negative 2.7k, and you actually need to simplify it here. Negative 2.7k subtract 4.8k, that will give negative 7.5k, negative 7.5k, like that, is equals to 3. So now let's get k. So k will be given by 3 divided by negative 7.5. Divide both sides by negative 7.5, and this will give k as negative 0.4, or you can write it as a fraction, negative 2/5. So that is simply how you're supposed to solve that question. Solve the equation 6 cosine squared of x plus sine x is equals to 4. For the range that is given, x should be greater than or equal to 0 degrees, and it should be less than or equal to 180 degrees, giving the answer correct to 2 decimal places. So that is the question. Now look at that equation, that trigonometric equation, and you can see we have 2 unknowns. We have cosine and we have sine. So it is not possible to work with 2 unknowns to get a solution from a quadratic equation. So one thing that we need to do is to either make all of them to be cosine or all of them to be sine. The concept that is going to help us to work out this is the trigonometric identity, and I'll write it here. Sine squared x plus cosine squared x is equals to 1. This is the identity that you're going to use, and using this identity we can make cosine the subject, and cosine squared x will be given by 1 subtract sine squared of x. So we are going to replace these or substitute these in the equation. So 6 cosine squared x, already we have obtained that cos squared x is the same as 1 minus sine squared x. We substitute that, plus sine x is equals to 4. Now you can see we've made these terms to be uniform. Now we have sine only. Now it is possible to work out these, and we're going to open the brackets here. This one will give 6 subtract 6 sine squared x plus sine x is equals to 4. We can reorganize these a little bit, and when you look at it carefully, you notice that this one forms a quadratic equation in form of sine. So if I reorganize it, I will have negative 6 sine squared x plus sine x, and then I bring 4 to the left hand side, I'll have 6 subtract 4, I'll get 2. Positive 2 is equals to 0. Once I've done that, I can eliminate this negative, where we have here negative 6 sine squared x, by multiplying each term by negative. So when I do that, I'll get 6 sine squared x subtract sine x subtract 2 is equals to 0. I've multiplied each term of that equation by negative 1 to eliminate that negative, where we have negative 6. Now, having this, you can see it forms a quadratic equation, and you can simplify it further by letting sine x be represented by a letter, let's say a. And when you replace that, you substitute sine x is equals to a in that equation, you shall have 6a squared subtract sine x is equals to a, that is a, then subtract 2 is equals to 0. I'm simply substituting sine x with a. So that is quadratic equation. You can solve this one using any suitable method. I'll use factorization, where I'll get two numbers whose product is negative 12 and sum is negative 1. That those two numbers are negative 4 and 3. So let me substitute them here. So I have 6a squared then plus 3a minus 4a minus 2 is equals to 0. I'm using factorization. Factorize, you have 3a is common, so you shall have 2a plus 1, then minus 2 is common, 2a plus 1 is equals to 0. So once you've done that, you shall get this one as 3a minus 2. So you shall have 3a minus 2, and then 2a plus 1. 2a plus 1 is equals to 0. So you have two solutions. The first one, you shall have 3a minus 2 is equals to 0. Here the solution will be a will be 2/3, or you shall have 2a plus 1 is equals to 0. The solution here, a will be negative half. Now you can see you have two values of a, but to remember what was a was sine x. That means for the first solution, sine x is equals to 2/3, because a was sine x. So you can get now sine here by simply getting x. You get x by getting the sine inverse of 2/3, the sine inverse of 2/3, and this one will give sine inverse of 2/3. This one will give 41.81. So x will give 41.81 degrees. Now that is the first angle, and look at the range that you're given here. You have all students take coffee. So in a unit circle, the range is given between 0 and 180, and those angles will fall in the first, where a sign positive in the first quadrant and the second quadrant. So we already have 41.81, that is in the first quadrant. So in the second quadrant, you simply get 180 subtract 41.81 degrees, and this will give 138.19 degrees. So you have two angles. You have 41.81 degrees, that is the first quadrant, and in the second quadrant we have 138.19. Now for the other solution, a is equals to negative a half. A is equals to negative a half. This will give sine x is equals to negative a half. We will not need this one. We are going to ignore this, and the reason is because we don't need anywhere where this one will give us where a sign negative. In the unit circle, these angles will fall in the third or the fourth quadrant, and that one will exceed the range that you're given. The range that you're given is between 0 and 180, where sign is negative, is in the third and the fourth quadrant. Therefore, we remain with two solutions. The first one is 41.81 and 138.19. The figure below shows a circle. Line CP and CQ are tangents to the circle at points P and Q respectively. So the figure is there. The circle is to be inscribed in a triangle ABC. Point B lies on CQ produced, and angle CBA is equals to 90 degrees. Use a ruler and a pair of compasses only to 1. Locate point O, the center of the circle. Supposed to locate point O, the center of the circle, and part B, to complete the triangle ABC. So let's begin with the first question, locating point O. Now, the information you're given is that the circle is to be inscribed in triangle ABC. So therefore, we have point C. What we are missing is point A and B. Point A and B will be located on this side. And then we'll be guided by this angle. Angle CBA is equals to 90 degrees. So let's go to the first part, locating the center of the circle. So how do we locate the center of the circle? We are going to use these points here, and you're going to use that property where we have the tangent and the radius meet at 90 degrees. So here we have the tangent, this tangent CP and tangent CQ. So if we draw a perpendicular, remember, if we draw perpendicular from Q and then another perpendicular from P, those perpendiculars will meet at the center of the circle, because one will be the tangent, this will be the tangent, and then we shall have the radius. So we need to construct perpendiculars from point Q and P. So let me start with constructing perpendicular from Q. So you stand at point Q, stand at point Q, and then from point Q you mark an arc there, mark an arc, and then with the same radius mark another arc. Then from there stand on this arc, then using a suitable radius, then mark an arc there with the same radius without changing it, then cut that. AB will pass through. So I've just taken this measurement from this point. So B will be located somewhere along this line, but CBA should be 90 degrees. So to ensure that I have CBA as 90 degrees, I will have to stand at this point and then I drop a perpendicular to this line. Where that perpendicular meets line CQ, and I have to produce this one. I have to produce this one just in case I need to make arcs. So I'll stand at this point, standing at this point Q, and then I drop perpendicular. I mark that arc there and another arc here. So I want to drop perpendicular to obtain B. So stand on this arc, and then using suitable radius, mark an arc there, and then stand on this point, and then cut that arc. Then I will join this point of intersection, this point here, intersection of this arc, through this point here, this point that I marked here. It will be a tangent. So through this point. So let me do that. Like that. So you can see I've joined this point here. I dropped a perpendicular from this point to this line so that I will have this one as 90 degrees, and this is where we shall have B. So point B will be here. Now you can see CBA, A will be located here. CBA is equals to 90. So I've completed that triangle by having CBA as 90, and I can see point A. So the triangle is complete, and that is how you're supposed to work out that question. The deviations of the masses of 10 students from an assumed mean are -10, -5, -2, 1, 4, 5, 7, 8, 9, and 13. The mass of the heaviest student was 58 kg. Calculate the mean mass of the students. Now we need to get 1280 and you're required to get the employee's taxable income, we need first to get the gross tax. We need to get the gross tax, and you get the gross tax by simply taking the net tax income for the second slab, then multiply by the tax rate is 15%, and this will give a tax of, when you work out that using a calculator, you get a tax of 1580 and 10 cents. 1580 and 10 cents. So now we are remaining with the last slab. So the first thing that we need to do is to first identify the total tax already we've got from the two slab. So we're going to take this one plus this one. So far we have 11, 18 plus 1580 and 10 cents. So let's see what we have now, and this will give 26.98 and 10 cents. So this is the tax we have already obtained from the two slabs, but we need a total of 34.80. So to get the remaining, we need to get the remaining tax will be obtained by taking 34.80, then we subtract 26.98. This is what will go to the third slab. So we subtract that, and we're going to get 781 and 90 cents. So this is what will go to the last slab. So the last slab, we already have the tax there is 781 and 90 cents, and we have the rate for that slab. The rate is 20%. So we have 20%. So what we don't have for that slab is the income that was taxed in order to give this tax 781 and 90 cents. So we let the amount for that specific slab to be X, the income that was taxed in order to get that tax of 781 and 90 cents. So this one we can simply get X. So X multiplied by 20% is equals to 781 and 90 cents. So working out this one, you'll get X will be given by 781 and 90 cents multiplied by 100 divided by 20. So this is what will give that amount that was taxed in the third slab, and this one will give, when you work out that 71 and 90 cents times 100 divided by 20, that will give 3909 and 50 cents. So that is the amount. So we got it. So the amount here will be 3909 and 90 cents. So that was the income that was taxed in that slab in order to give that tax of 781 and 90 cents. Now, after doing that, now we need to get the total. Plus 4y, we need to complete that square, and this one is equals to 0. So to complete this square, x squared minus 3x, you know how to do this. You simply get divide the coefficient of x, which is negative 3. So negative 3 divided by 2, you square that. And then for y, this is 4y, get the coefficient of y, which is 4, then divide that by 2, and then you square that, is equals to, now whatever you added points A, B, and C are collinear. A particle starts from point O and moves in a straight line so that its velocity v meters per second after time t seconds is given by v is equals to 90 squared minus 18t plus 10. Calculate the distance covered by the particle between the time t is equals to 1 and t is equals to 2 seconds. So that is the question. So the question, you're supposed to find the distance covered between these times, and you're given the velocity. Now, one thing that you need to understand is once you're given velocity, to get the displacement or distance, you are going to integrate velocity. So distance, you get it by integrating velocity, and you're going to integrate velocity between these times from t is equals to 1 to 2 seconds. So that is what you need to do. So now we integrate velocity to get distance. So distance is given by, we integrate this expression for velocity from t is equals to 1 to 2. This is 9t squared minus 18t plus 10 with respect to t, like that. So once we integrate this 9t squared, you get 9t cubed divided by 3 minus 18t. Integrate that, you get 18t squared divided by 2. Then integrate 10, you get 10t. Then plus the constant of integration. Put the square brackets from 1 to 2. So let me simplify whatever is said here. This will give 9 divided by 3. This will give 3t cubed minus 9t plus 10t. Then plus the constant of integration, like that, from 1 to 2. So after doing that, so the next thing now we're going to do is simply to substitute t with, we are going to first substitute t with 2. So 3, then this is a 2 cubed minus 9, t is 2, then plus 10, t is 2, like that. Then close that bracket. Then subtract, substitute 1. So you have 3, this is a 1 cubed minus 9, 1, like that. And this is a squared. I forgot to put squared here. So this one is 9t squared. So this one should be squared, like that. So 1 squared plus 10, 1, like that. And the constant of integration, you can drop it, because even if you continue with it, the constant of integration will be subtracted and it will be 0. So that is why I have dropped it. Now after that substitution, ensure you have done the correct substitution. I'm confirming 3t cubed minus 9t squared, like that, is okay. Now work it out. You get this is 3 times 8. This will give 24. Subtract 9 times 4. You get 36. Then plus this one will give 20. That. Then subtract. We have 3. This one will be 3. Subtract 9 plus 10. Like that. Then from there you have 24 plus 20, that is 44. Subtract this one will give 8. And then the whole of these will give 13. This will give 4. And this one, 8 subtract 4, you get 4 meters. You get 4 meters because you're getting the distance. And you say to get the distance given the velocity, you integrate velocity. The following table shows the number of units U of water consumed by 6 households in a month. The corresponding amount A charged is also given, so the table is there. Part A, using the scale 2 centimeters to represent 1 unit on the x-axis and 1 centimeter to represent 100 shillings. On the y-axis, draw the line of the best fit for the data on the grid provided. So already the scale is given, so let me begin by going to the y-axis where we shall have the cost in Kenyan shillings, and then you have the units on the x-axis. So on the x-axis, 2 centimeters represent 1 unit, so that means that 1 centimeter will represent 0.5. That is what it means. So this will be 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. I can see the largest is 4.2, so you can stop at that. And then for the y-axis, 1 centimeter, 100. So this one will be 100. That is 200. That is 300. 400. 500. 600. 700. And can go up to 800. You can see the largest is 720. Now once we're done with putting those values, let's go to plotting. And also you should understand the size of one small square in each case. Like in the x-axis, one small square will be, so this is 0.5 divided by 5 squares, so it will be 0.1. that is in the x-axis. Then in the y-axis, we have 100 divided by 5. One small square will represent 20. So with that in mind, now we can go to plotting. The first one is 0.8 units, 0.8 units, 200. So 0.8 units, 200, 0.8, 200 will be there. So 0.8, 200 will be there. 1.7, 340, 1.7, 340. So these are 1.6, 1.7, 340. So 340 will be there. Yeah, it will be there. 320, 340 is okay. Then 2.2, 380, 2.2, 380. So 2.1, 2.2, 380 will be there. Okay. And then 2.9, 480, 2.9, 480. 2.9 is here. 480 is there. 2.9, 480 is okay. Then 3.5, 600, 3.5, 600 is there. And then 4.2, 720, 4.2, 4.2, 720 is there. 4.2, we reach 4.2, 720. Let me indicate it properly. 4.2, 720 is there. Now after doing that, the next thing now, you're supposed to draw the line of best fit. Draw the line of best fit. Now the line of best fit is a line that carries most of these plotted points. So you need to check all these plotted points here. And the line that you're going to draw, you should ensure that that line will contain most of the points. That is the line of best fit. So try to use a ruler for this. You can try to check which one, how many. Try to draw all the possible lines. Or somewhere I plotted, I didn't plot correctly, I've noted. So for 4.2, 4.2, just check 4.2. 4.2 is 720. I had plotted 820 instead. 4.2, 720. Now it is supposed to be there. 4.2, 720 is here. So you can confirm all the points. So 0.8, 200, 0.8, 200 is there. 1.7, 1.7, 340, it is there, is okay. 2.2, 2.2, 380, 380 is okay. 380 is here. Is there, and then 2.9, 480, 2.9, 480 is there, and then 3.5, 600. This one is at the corner here. 600 is there, and then the last one 4.2, 4.2, 720. So now I've confirmed all the points are okay. So let me try to see the line of best fit that I can be able to construct. So the line that will contain most of the points, so you place your ruler and try to draw. Let me see, that one will contain only 2 points. So there's another one here. Maybe if I can so I'm trying to see to place. Need to be very keen when you're placing, so that you can see I can get a line of best fit there, and get a line of best fit there. There's somewhere I can see here. So this one, the one that I've placed, I can see I'll have a point here, I'll have another one here, and I'll have another one here. Those are 3. I don't see whether there's any other line I can draw. So if I draw that line, like that, you can see that that line that I've drawn contains at least I can see there's a point here. I'm sorry. So you can see there's a point here. There is a point here. There is another one here, and there is another one here. So those are 3. Those are 3 points. At least 3 points are on that line. So I've tried to check whether there is any other line I can draw that will contain more than 3 points. I don't see. So that is the line of best fit. It contains most of the plotted points. And now with that, now we can proceed to the other question. can proceed to the other question, which is estimate the cost of 1.5 units. 1.5 units. So 1.5 units, how do you get that? You simply need to go to where we have 1.5 units. And this is where you have 1.5. When you draw a straight line up to where we have the line, and then you move to the left like that, straight to the left, you'll be able to read this value here. It is not exactly at 300. It is slightly above 300, and it is not yet 320. It is somewhere in between 300 and 320. It is not exactly between when you draw it properly. Let me try to draw it again. So as you can see, it is not exactly on 300. So it is slightly above 300 and not yet to 320. So 1.5, you draw a straight line, 1.5 up to where it touches the line. Then to the left, you read that value. So that I can estimate that value to be around 10. So it will be 300 and then plus 10. It is not yet to 320. So that will be 310. So that will be the cost. So for that question, the cost of 1.5 will be 300 plus 10, which is 310 shillings. So that is how you're supposed to work it out.